So let's get started. Hello, everyone, and thank you for joining our Kubernetes Cloud Native online meetup tonight, a bit belated. My name is Christine, and I'm from Lotse, and I'm very happy to soon welcome Matt Jarvis from D2IQ as our speaker. And Matt will be presented the Kudo project, which facilitates building Kubernetes operators. And we all know that Kubernetes operators have become like the top hot topic in the Kubernetes world over the past month. So very exciting to see us talk. We are Lutze. We are a Kubernetes software company from Hamburg, Germany, and run various Kubernetes meetups. We are a team of around 60 people. We are based in Hamburg, Germany, but distributed around the globe. And what we are very, very proud of is that in 2019, we have been the #5 top committer to the Kubernetes project, just right after companies like Google and VMware. And this is really a great achievement of our team. So that's shortly on us. We do have various projects and products. We have Kubernetes platform, which empowers companies to easily deploy, manage, and run hundreds or even thousands of Kubernetes clusters on any infrastructure. And we do have like the smaller version of it, the nice fish, Kube1, which is an open source project. And Kube1 is a Kubernetes cluster lifecycle management tool that also works on any cloud, data center, edge, or IoT environment. And then finally, we do have a brand new project. It's also open source. It's called Kubecarrier. It's still super secret because we haven't announced it officially yet due to the virus. We internally like to call it the operator of operator because it creates a meta platform for operators, so you can manage your applications and services across multiple Kubernetes clusters. So if you're interested in that, you can already check it out on GitHub and be one of the first to try it. Exactly. So I see Matt Jarvis is now online, so we can start. We will have a short Q&A session after his presentation. So if you have questions, just type them in and we will answer them after the presentation. And yeah, I hope you enjoy the meetup.
Hi folks, can everyone hear me okay?
Yes.
Great. Okay, fantastic. Right. Let us just get this show on the road. So let's start with this one, hopefully. Okay, hopefully you're seeing my slides there. Please shout if you're not. So this is me. My name's Matt Jarvis. I'm Director of Community at a company called D2IQ. D2IQ are a cluster orchestration software company based in San Francisco, previously called Mesosphere. We've been around the world of container orchestration from before Kubernetes and from before Docker, historically in the field of Apache Mesos, but now also working on Kubernetes. So just to set the scene a little bit for what we're going to be talking about today, Kubernetes and other orchestration systems built around this idea of declarative state work very well for stateless applications. And a stateless app, as I'm sure most people are aware, is a program that doesn't save client data generated in one session for use in the next session with that client. So every session is carried out as if it was the first time, and responses and stuff that happens there isn't dependent upon data from a previous session. So in practice, what that tends to mean is that we can stop and start our stateless applications and they all just start executing. In general, we'd run this kind of application behind a load balancer, and we can scale up, scale down, just by adding or removing instances. And we can also deploy new versions pretty easily by just replacing all of our running instances. And we can have various ordering strategies for how we do those tasks. We might have blue-green deployments for testing new versions, but fundamentally the management of these applications is kind of binary. We're either running or we're not. And stateless applications are intrinsically intertwined in the move towards microservices architectures, where we connect many very simple applications which each have a particular well-bounded function. And it's also connected to the adoption of container technologies to manage them, because they're fundamentally well suited to the patterns that systems like Kubernetes give us. We just declare we want the specific number of an application to exist, and Kubernetes will create them for us. And again, it's basically this idea of a binary process. They're either running or they're not. And we don't have to worry about any complex operations to configure them before we start deploying. So if all applications were stateless, then the world of application deployment would be super simple. And sometimes in our industry, you could get the idea that that's the case in this era of microservices. But unfortunately, that's not actually true. The second class of applications is stateful, where the app is retaining data or state across its entire life cycle. And whilst older, more monolithic applications like SQL databases, for example, fit into this paradigm, there are also many architectures where the individual elements making up a particular service are actually clustered together in some way. They might be sharing data between them, or they need to be synchronized together. So that conceptually is a lot more complicated, and it's a whole area of computer science unto itself. But typically these kinds of applications have a set of lifecycle states that require logical ordering of actions in order to maintain operation. So in general, we can't just start and stop instances and expect the overall service to continue to operate. We might need to wait for data to rebalance, or there might be multiple steps involved in something like an upgrade operation. And that applies not only to upgrading, but it applies to scaling, it applies to failure scenarios. And these operational strategies require domain-specific knowledge to manage them. So they're unique to the application, and those operations for a Cassandra cluster are very different from a Kafka cluster or an HDFS deployment. So although these things are fall under this umbrella of stateful, they look pretty different. Cassandra has this kind of ring architecture, and then something like Kafka has this combination of brokers and stuff like that. So Kubernetes was originally very focused on stateless application architecture. One of the fundamental features of Kubernetes is that the scheduler can move pods around between agents. And this works fine for stateless applications, but not so well for stateful. They tend to like their storage and networking not to change during operation unless we handle that in a very specific operational way. So in order to try to handle the complexities of stateful applications, Kubernetes added this concept of stateful sets. And that adds in, broad brush approach of giving us stable network and storage. But this doesn't really solve all the problems with stateful applications, because Kubernetes still doesn't know what's actually going on inside the pod, inside the application. So, it's a pretty generic approach, and it doesn't really give us that visibility into what the application is doing. So the emerging solution to this problem is the operator pattern. And operators basically encapsulate operational tasks in code, These can be run, you know, when an API is called. It can be run automatically on a schedule, whatever. But it allows us to orchestrate application lifecycle actions using Kubernetes APIs. So operators fundamentally encode that domain-specific operational knowledge about the lifecycle actions required for an application. So how do I scale it? How do I upgrade it? How do I deal with failure scenarios? And then they repackage that, bundle it up, so you can have access to that human operator knowledge using native Kubernetes APIs. So what are operators? Typically when we install an operator, we'll likely get the operator itself, the controller, and that has the code that manages the life cycle of the particular thing. And it's where that domain-specific knowledge is encapsulated. And we'll also likely get a bunch of custom resource definitions and CRDs, and these extend the Kubernetes API to address new resource types, which you can then put data into and instantiate. So, you know, the fictional example there is a type for a MySQL cluster. And then we would just apply that in YAML and fictitiously create our MySQL cluster. But it's important to note that operators mainly are unique, so they're purpose-built for each application. And up until now, there have been two main ways of building operators. There are a bunch of other different ways that aren't represented here, but the first one is the operator framework. This is kind of where the original idea of operators came from. It originated at CoreOS, which was later acquired by Red Hat. And you can, using the operator framework, you can build operators using Ansible or Helm, but there is also a Go SDK, and for complex operators, you really end up needing to use that Go SDK. And then there's the KubeBuilder project, which is part of the API Machinery Special Interest Group in the Kubernetes project. And that's focused on extending the Kubernetes API. And again, you're going to need to write a lot of Go to build operators using this. So I guess the point that I'm making here is that building operators can be very complex, and it requires a lot of knowledge about how Kubernetes works internally, and deep Go expertise, as well as the domain-specific knowledge about your application. And the engineering effort that goes into high-quality operators built in these ways is very considerable. So as an example, one of the major NoSQL vendors have an operator that's very feature-rich. It's probably the most feature-complete one that's out there at the minute, but it's over 40,000 lines of code and took 1 man-year of effort to write. And even something like the etcd operator has around 9,000 lines of code, and etcd is a fairly straightforward application from a lifecycle perspective. So this is where Kudo comes in. Kudo is an acronym. It stands for the Kubernetes Universal Declarative Operator. And rather than implementing a custom operator for each application, Kudo provides a universal operator with a set of concepts built into it that allows operator developers to define a lot of the code declaratively in YAML. So it provides a kind of framework for operational sequencing and actions, allowing you to ship your application together with basically a run book of how to operate it. Kudo is a fully open source project. It's licensed under Apache 2.0, and we're actively working to build community around it. So in comparison to those other ways of building operators, Kudo's polymorphic. So you only ever have one controller running in your cluster, and you can create pretty complete operators without needing either deep knowledge of how Kubernetes works or also to writing any code. So there's some core concepts that we need to understand when we talk about what Kudo is. Firstly, an operator in Kudo terminology is a description of a deployable service represented as a CRD object. Then we have this idea of operator version, and this represents a particular implementation of an operator which contains the plans, the objects, the parameters for that operator. And the purpose of the operator version is really to provide the details necessary for Kudo to become an operator for a specific capability, like Kafka, Zookeeper, whatever we want to control, and also for a specific version of that operator. So it's a specific version of a deployable application, including configuration and lifecycle hooks for deployments, upgrades, rollbacks, etc. It's a complete definition of the application to be installed with a bunch of parameters that we can override. And then we have this instance CRD, where the instance ties a particular application instantiation, a thing running in your cluster, to an operator version. So it's an actual deployment of whatever you're controlling using Kudo. And the important thing about the operator version CRD is it allows us to have multiple versions of the same software running within our cluster. So we might want to run a particular version of something like Zookeeper and run multiple different versions within our cluster. And without the operator version, we couldn't do that. So plans are how Kudo operators convey progress through service management operations, like deployment, like scaling, like upgrading. And a plan is composed of phases, and these in turn are made up of steps, and steps are made up of tasks. And we'll look at this in the demo that I'm going to run once we finish the slides. But plans orchestrate tasks through phases and steps. So, and both phases and steps can be configured with an execution strategy, either serial or parallel. Kudo also includes a CLI extension to kubectl, and again, we'll see that in the demo. That allows us to run Kudo-specific commands natively in kubectl. It's all just Kubernetes. There's nothing proprietary here. It's just an extension to kubectl. And so we'll look at a high-level architecture diagram of what all this looks like in your cluster. We've got the Kudo controller and the Kudo CRDs installed in our cluster here. The kubectl extension installed into kubectl. And then we use that to install operators into our cluster, either from the upstream GitHub repository for Kudo operators or locally from a file system. And in our fictional cluster here, we've got the Kafka operator running, 2 different versions of Kafka in operator version CRDs, and we have an instance of one of those operator versions, so an actual Kafka cluster running there. So let's take a quick look at Kudo in practice. So let me just stop that one and go to this one. Bear with me 1 second. So you should be seeing a terminal now. Please let me know if you're not seeing that. Let me just make that a bit bigger. Clear that. So before we start, let's have a quick look at what one of these operators actually looks like. If we take a look in this Zookeeper operator, the operator layout is standardized, so we always have the same file system layout when we create an operator. And if we look at some of these files here, we can see that in our operator.yaml file, this defines which versions of the particular thing we're looking at. And we define a set of tasks that are associated with a set of YAML files. And so when this task is invoked, these are the YAML files that will get run. And then we also define our plans, phases, and steps here. So we can see which tasks will be run for a particular step. And we can see that, for this deploy step, we have these infra and app tasks, and we'll see that running in a minute. We also have a params file, which these define all of the things that we can override within our operator when we actually run up an instance. They've all got the sensible defaults, but we can override those when we invoke the operator. And then if we look in our templates directory, we can see those files that were referred to in our tasks. And if we look into one of these particular, one of these task YAML, we can see that we have templating going on here. So these templated entries will be overridden by the parameters. So Kudo knows how to take those parameters and interpolate them back into those YAML files when those YAML files are actually invoked. So let's just, hopefully I have a Kubernetes cluster here. So this is a clean Kubernetes cluster I just deployed into AWS. And we've got no pods running there at the minute. And if we try to get operators, we can see at this point, not only do we not have any operators, but our Kubernetes cluster actually doesn't know what an operator is. So the first thing that we're going to do is to install Kudo into our cluster. And we have a shortcut to do this within the Kudo CLI extension. So we can just do kubectl kudo init, which will install Kudo into our Kubernetes cluster. And so if we look at the CRDs that we have installed, we now can see that we've got our standard Kudo CRDs have been installed. And if we look at API resources, we can see we have the same available, all namespaced into our API group of kudo.dev. And we have our Kudo controller manager pod up and running. So Kudo is now fully functional within our cluster, and we can use it to start installing stateful applications. So the first thing that I'm going to do is to install Zookeeper. And when I call the Kudo CLI extension like this with install, this is going to install the Zookeeper operator from the upstream GitHub repository for Kudo operators. And we can now use the Kudo CLI extension to look at what plans exist in that Zookeeper operator. And we can see that's the same stuff that we saw in the GitHub repository for the definition of plans at our top level in that particular operator. And we can also use the Kudo CLI extension to look at what the status of a particular plan is. So as we can see from the output here, we've got the deployed plan is in progress. And that deployed plan consists of two phases. The first one is executing in parallel, which will be the actual deployment of our Zookeeper pods. Because we know in a Zookeeper that we can bring all our pods up at the same time, and we don't need to wait for each one of them to come up before we start the next one. And we can also describe this particular instance, our Zookeeper instance. It's going to give us some nice metadata, and our plan status also comes up in the output of kubectl describe. And we can look at some of the entities that this operator is creating here. So I know that that this operator creates a stateful set of 3 instances of Zookeeper. So it's giving us a highly available Zookeeper straight out the box. And now when we use kubectl to say get operators, not only does our Kubernetes cluster know about the concept of operators, but it knows that we also have a zookeeper operator running. And again, we can get operator versions and see we've got zookeeper-0.3.0 in our cluster. And if we describe that particular operator version, there's a lot of output here, but what's actually happening here is that the entirety of the YAML files that we saw in the GitHub repository are actually contained now within that operator version CRD. So it's all being stored in our cluster, the parameters, the config files that were in that directory, everything is now stored inside that operator version CRD inside our cluster. So Kudo has access now to all of that configuration all of the time in order to run the Zookeeper application in this way. So the next thing we're going to do is install a Kafka cluster, and Zookeeper is obviously a. Actually, let's just make sure we have finished that deploy plan. It should have finished by now. Yeah, so we can see our Zookeeper deployment is now complete. So with Kafka, I'm going to do something slightly different. I'm going to say skip instance and just install the operator without actually installing a Kafka cluster. And again, this is going to install from the upstream repository. And when we take a look at this particular Kafka operator, we can see that this operator has quite a complex set of steps and phases, different things we can do here, adding external access, mirror maker, enabling service monitoring for Prometheus. So now what we're going to do is actually install an instance of this operator. Just go into the Kafka operator here. So I'm just going to show you how we can do things from a local checkout of an operator as well. This is the operator repository on my disk. What's going on here? I think this operator repository has actually been upgraded since the last time I ran this demo. Right, okay, let's install a Kafka operator. Let's actually install a Kafka cluster. Oh, what's happening here? Sorry about this, slight technical problems. Not quite sure what's happening there. Right. Okay, plan B. I'm not quite sure what's happening there. I actually recorded this demo earlier, so let me just switch to my recorded version. Okay, so before we get going, actually, let's just mute that and reshare my screen. And let's just move through to where we left off. Okay, So when we've seen that, I've installed the Kafka operator here from the upstream repository and skipped the instance, but you can see this version of the Kafka operator has a fairly limited set of plans. So instead of using that one, I'm actually going to use the one from the my GitHub master branch. Again, this has exactly the same layout as our Kafka operator, as our Zookeeper operator. And in the version that I have on my disk, we can see that the operator is much more advanced. It has a whole set of additional plans and phases in there. So we're going to install an instance of the one that from my local Git checkout. And we can also use the Kudo CLI extension to list what tasks are available, again, looking at that one on disk. And we can look at what parameters are available for that particular operator. So I'm now going to install an actual Kafka cluster using the local checkout, and I'm going to override one of the parameters on the command line using the -p switch. And so by default, this operator will install a 2 meg broker memory, but we're going to, in this instance, go with 1 meg. And we're starting to see now the pods deploying for this Kafka cluster. The first task there is a pod to generate TLS certificates, which are shared between the Kafka instances. And we can use the CLI extension again to look at what's the status of our plan is. So we can see the deploy plan has started there. And now we're just waiting for the instances of our Kafka cluster to appear. And again, the CLI extension will show us that our deploy plan is executing. So we'll just watch the output of there. We should start to see our Kafka instances starting to deploy. So there's our first instance coming up. And again, we see that the TLS certificates task start to execute. Let's just zip forward slightly. So there's our second Kafka instance coming up. And so finally, that's our third Kafka instance creating. So at this point, we've now got a fully functional Zookeeper cluster, HA, and a fully functioning Kafka cluster, and really just with 2 commands to install both of those operators. So what I'm looking at there is the logs of the first Kafka instance. We can see that we're seeing correct logging in our Kafka instance. And then I've started a shell inside my cluster just to get the output of the Kafka metrics API. So we can see that, that Kafka is working correctly there. Okay, let's just stop this and go back to my slides. again here. Okay. So we saw there the Kudo operator for both Kafka and Zookeeper in practice. And you know, hopefully by looking at those files on the disk, you can see how much easier it is to be able to write these things without writing any Go code. So there's a bunch of interesting stuff happening in terms of the Kudo roadmap. Kudo's a very fast-moving project at the minute. We have just in the process of going through the process to get Kudo into the CNCF as a sandbox project. And there's a bunch of exciting stuff on the roadmap. Firstly, this idea of dynamic CRDs. So this is where we can have CRDs actually created on the fly once our operator is already installed in our cluster. So it might be that as a human operator, I want to change how a particular plan is executed. It might change the ordering of particular actions or add some new actions. Or I may want to change what happens on a particular plan trigger. Using dynamic CRDs, we can do that on the fly. We're also looking at a lot of tooling around how to extend other formats to allow them to be the basis for new Kudo operators. So allowing you to use Helm charts, for example, as a scaffold for starting off a Kudo operator. Lots of folks in the Kubernetes community are looking at using things other than YAML. YAML, once you start getting into very long files, is very hard to read. And there are lots of interesting things happening like Starlark and Q, which basically make that experience of working with YAML a lot more interesting. And one of the new things that's just landed that we actually saw in practice with the Kafka operator is this idea of pipe tasks, where we can generate something within one task and then use it as the input to another task. The example in Kafka was those certificate generations, that those are a task unto itself, but we take the output of that task and use it as the input into another task. So if any of this has been interesting, there's a whole bunch of ways you can learn more or get involved with the Kudo community. There's a website at kudo.dev. Well, everything that we've just looked at today is in GitHub, in the Kudo Builder GitHub organization. The main one is Kudo, but also the website, the operators, everything else is in there. The main focus for development is #Kudo on the Kubernetes Slack. We also have a mailing list where you can see the link there. And we have a weekly community meeting on Zoom where folks can just turn up, listen to the discussion, ask the developers stuff. So please, if any of this has been interesting, do get involved. We'd love to have more people using and more people developing the project. So that's all I've got. So I'm happy to take any questions.
Yeah, as said, if you have questions, just put them in the chat so we can read them aloud, and then Matt can answer them. Right now, I can see, seems like you answered all the questions.
Okay, well, I'm available. You can contact me on Twitter, on LinkedIn, through any of those mechanisms. I'm happy to take questions afterwards or at any time if folks have things they'd like to know more about the project.
All right, then thank you very much, Matt, for speaking and showing us the project. Sorry again for the inconveniences at the very beginning.
That's all right. I'm sorry. It's my fault. I'm doing so many of these virtual events at the minute. I get confused in my time zone, which time zone I'm supposed to be in.
Yeah, but in the end, we managed to get the group together. Yeah. So thanks everyone for joining. In case of questions, contact Matt, contact me, and then we also recorded that webinar and will make it available on our YouTube channel.
Great.
So I wish you all a great rest of the day. Bye.
Thanks, folks.